This is Maths Concepts. Today, what we're going to be looking at is our first lesson in Algebra 1. Today's lessons we'll be dealing with parent functions. So here, there are some key features of a parent function, and we will want to look at them, try to identify them the moment we see them. We want to make sure that those distinct features are notified. Stay tuned, I'll be right back. Welcome back to Maths Concept. So what we're looking at here is our first parent function. And the parent function that we're looking at is a linear function, right? So a linear function here will suggest that we're dealing with what is called a straight line. So if you take a look here, we'll have noticed that we're seeing a straight line. That's what the linear means, right? Line. So we're dealing with a straight line. The equation of this line, though, is, as you could see, y is equal to x. If we take a quick look at the table here, we're going to notice that because the equation of a straight line suggests that y is equal to x, this is the parent function, then for every x, the y value is the same. For example, if x is -2, y is -2. If x is -1, y is -1. If x is 0, y is 0. And as you could see here, for every x value, the y value is the same. Hence, it is y equal x, right? Now, if we take a quick look at the 4 quadrants, because this is our x-axis and this is our y-axis. This is quadrant 1, 2, 3, and quadrant 4. Whenever we're dealing with y is equal to x, right? Based on what we're seeing here, we're going from quadrant 3 to quadrant 1, right? So y is equal to x. We're going to get into this as we go to the second lesson, but this is our first lesson on functions, parent functions. Let's take another look. So here we're looking at the quadratic function. And for the quadratic function, we're dealing with the square, right? So the quadratic function, whenever we have any form of polynomial, and the highest power of the variable is raised to the second power, it is a quadratic, which means that we're going to get a U shape, right? We're going to get a U shape. And this is the parent function. So one of the features that you could use that it's going to remind you of a U, okay? It's going to remind you of a U, and that is a quadratic. So the equation for the quadratic is actually y equal to x squared, right? And as you could look, if you take a quick look at the table, y is going to equal to x squared. For example, if I square this, square -2, I get 4. If I square -1, I'll get 1. If I square 0, I get 0, and so on. If you square all of these numbers, you're going to get these. So we're saying here to take a look, y is equal to the square of x, right? Another thing we want to look at is these are the quadrants. There are 4 quarters when you draw your x and your y-axis. The quadratic function actually starts in quadrant 2 and it finds its way back in quadrant 1. That's the parent function, right? Hence, we get this U shape, right? Right, so let's take a look. Let's look at the third one. Now we have a cubic function. Cubic function. When we hear cubic, we're thinking of third, right? Now let's take a quick look at the graph itself. So what it's looked like to you, right? So we have this elongated shape starting in the third quadrant. Take a look. So it's coming from quadrant 3, and it goes all the way up to the center, and it goes. So the cubic function will be coming from the third quadrant. The parent function will pass through 0, and then it goes up to quadrant 1. Hence that shape that we're looking at. Now, so remember though, that for this, the power is going to be the third power. The highest power of the variable is the third power. And if we should take a quick look at the table, whatever value you have for x, if you should raise it to the third power, you're going to get the y value. And that is why it is called that y is equal to x cubed. Negative 1 to the third power is negative 1. 0 to the third power is 0. And these are the coordinates that you'll get. And if you should cube these, we're going to get these, right? So let's take a good look at what this cubic parent function looks like. Started in quadrant 3 and ends in quadrant 1. Square root function. Now, the square root function, take a look at it. Look at what its shape's like. So you can see it starts right here where 0 is, and then it topples off, and it's going like that forever, right? And you can see it's getting taller as well, because if I should say, take a quick look, it's getting taller as it goes. So that means it's going to be getting taller as it goes to the right, right? So that's one thing you want to look at. You want to look at the fact that it did not go underneath the x-axis either. It did not go in the negative area. It did not go there, right? And we're going to talk about that, in more details when the time comes. Let us take a quick look at what the equation is. The equation says y is equal to the square root of x, because it is a square root function. Now, because of that, if we should take a quick look at the table, let's take a look at the table. So what we have for the table here is, if we take the square root of negative 1, in Algebra 1, we're going to say that this is not real, right? It is not real. Now, of course, we're going to say, all right, it's not real, but it is an imaginary number. But in Algebra 1, we're not going to go in details in that. Matter of fact, we're not even going to be looking at imaginary numbers. So we're not going to have a value here. There is a value, but for this course, we would not elaborate on it. So we're not going to get anything negative right here, right? So we're going to start at 0. That's going to be your first number. So the square root of 0 is 0. Square root of 1 is 1. Square root of 2 is 1.4, and it goes on and on. And then we get this. So the square root function starts at 0. There's no negative numbers either. So you're not going to use any numbers in the negative aspect, or you're not going to use any. So wherever the negatives are, you're not going to find it. So it's just going to be in quadrant 1. Let's look at the cubic root function. The cubic root function, on the other hand, is quite different. It resembles a S, right? So if you want to say the cubic root function looks like an S, that's fine. Use a key feature to remind yourself what it is. Now, let's look at the shape. It would have almost looked like the cubic function, but it's more like it's compressed. So here it is. Let's take a look at the equation. So the equation is going to be the third root of x. Not the square root, the third root of x. And this is where it's coming from quadrant 3, just like the cubic, and it's going to end up in quadrant 1. But it's more of a compress, so it almost wants to look like an S, right? If you look at the table of values here, if you find the cubic root of negative 8, it's a negative 2. Cubic root of negative 1, it's a negative 1. Of 0, it's 0. 1, it's 1. Cubic root of 2, and it goes on. So we're looking at the cubic functions, and this is what it looks like. Shapes like an S. An absolute value function. One of the key things that that a lot of students always say the moment they see this is that the absolute value function, it looks like a V. So the moment you get a V shape, you should know that, hey, we're dealing with the absolute value function. Another thing is that the symbol for an absolute value in mathematics is we have two strokes. Some may use the term modulus, right? So the absolute value of x, the equation says y is equal to the absolute value of x. And the absolute value really means the distance from zero. So a distance is always positive. So an absolute value will always be a positive value. For example, the absolute value of -2 is +2. The absolute value of -1 is +1. And you'll see the absolute value of any number is always positive. And that is why you notice that the parent function for the absolute value is not in the negative aspect of the graph. So it did not go onto the x-axis. Now, if you look, it started in quadrant 2 and it ends in quadrant 1. All right? So there's no quadrant 3 and quadrant 4 for the parent function. So here it is, we have exponential function. There are two types of exponential function. Let's look at exponential function 1. Now, this is the parent function for the growth function. And as you could see, let's take a look what it looks like. Well, whatever shape you want to have, whatever idea you think it reminds you of, that is correct. But it's coming from these quadrants. Now, if you notice in quadrant 2, it's closer to 0, very close to 0, right? And then as you move horizontally in this direction, it's getting taller. So this is like almost 0, tending to 0. And the further you're going to the right, it's climbing like that. And it goes on to infinity. So the exponential growth function is coming from the second quadrant and it's going to the first quadrant, right? And it does not go beneath the x-axis either. Now, we're going to study in details in another lesson about the y-intercepts and the x-intercepts. But for now, what we want to do is just to look at the main features. The reason why it's called an exponential function is because the variable is in the exponent. For the other functions that we looked at, the variable was not an exponent, but the exponential function says that the variable must be in the exponent. The parent function for all exponential function is 2 raised to the x, right? So y is equal to 2 raised to the x power. If we have 2 raised to the -2, we will get 1 over 4. If we have 2 raised to the -1, we'll get 1 over 2. If we have 2 to the 0, we'll get 1, and so on and so forth. All right? So this is simply our exponential growth function because it's getting taller. On the flip side, there is what we call an exponential decay function. So with the exponential decay function, it's going to be, we're dealing with a proper fraction there. We have a half. This is the parent function of those types. So the numbers will change, but this is the idea. The exponent, you could see that the variable is still in the exponent. And whenever this number is less than 1, as you could see here, it's a fraction, a proper fraction. It's decaying because as you move from left to right, it's dropping. So it's dropping until it's tending towards 0, right? So it's dropping. So we want to make note of that. So it is very, 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 very contrary to the one, because with the first one, the idea was like this, right? And with this one, it's coming the other direction. So the growth and the decay, they are kind of a flip to each other. All right, we're going to look at that as we go on. So as you could see, this one does not go below the x-axis either, does not go in the negatives. And you can see that it starts in quadrant 2 and it ends in quadrant 1, right? So it is decaying because the values are dropping as it goes, right? So basically, that is just a quick introduction to lesson 1 in Algebra 1. Make note of those key features. See you next time. Bye-bye.